Howdy ho, Arkansas Pilgrim here again to coin a phrase, and now for something completely different. All right, before we get to the completely different part, let me remind everybody what I'm doing. Out here in my workshop, I have a dust problem. Anytime you cut wood, you get a dust problem. So rather than going out and buying a marginally good dust collector like at Harbor Freight, I decided I was going to try to make one myself. And I'm using this, like I said in my previous video, and there'll be a link in the description. I've got this old blower from a small bounce house that my mother-in-law bought for my kids years back. And then when it broke, or at least the bounce house itself got some holes and got tore up, I kept this blower with this in mind. I'm going to use it to vacuum in the dust and blow it outside through a pipe. The trick though is I've got to make something to actually attach the hose, the fitting that goes like on the table saw, which was from an old shop vac. It's a standard size. Well, there's a big hole in here, yeah, where it can suck the dust into and blow it out through the van. And I got to convert that down to the basically 2-inch pipe size. Well, this is 4-inch duct, and it has I'm going to put this in here and then reduce it down. Well, I don't really want to go buy a reducing duct. They cost way more than I think they ought to. They're like 15 or 20 bucks, maybe even 25 bucks if I remember correctly. Well, I've got some sheet metal here, and it's, so it's basically making what you call a truncated cone, and you'll see a diagram of that in a minute. Anyway, the best way to measure this isn't, this is supposedly circular, but to get an accurate measurement, and you can do this for anything that's a circle, especially big ones, either for measuring for determining the diameter, or for making a nice across, perfectly perpendicular circle around the pipe to be able to cut it off, which at some point I'm going to do, I'm also going to do. What you do is you take a piece of paper. Now this one needs to be bigger than a regular sheet of paper because it's actually more than an 11 inches around. 8.5 by 11 paper. But as you see, you get a wide strip of paper and you wrap it around. But you just have to make it where it lines up perfectly. When it lines up perfectly, it'll be perpendicular across the pipe. So you just have to fudge it around a little bit. Maybe a lot. There you go, I've cut a piece out of the paper. As long as the paper is longer this way than the diameter of the pipe, you should be able to get a nice perpendicular. There we go. There, it wraps around nice and clean, and you find the spot where the paper overlaps. Am I doing this right? Yeah, and just make a mark there. Now, if you're gonna, obviously you'd make a mark around the pipe if you were gonna cut it, but what I want is the circumference, and there we go. Now I just need to measure that distance. Now we got some numbers to work with, and now we'll get to the something completely different part. First time I'm doing a screen recording, if I recall correctly, and I'm also going to be putting chapter breaks in this video. because another first thing I'm doing is I'm going to kind of do some math here. I may have sort of done that a little bit before, but it'll allow those of you that don't really want to see that to skip to the end. Please don't skip to the end at right from the beginning, because what I'm going to be doing mostly is showing, when you're designing something, how what kind of steps you go through and kind of the thought process of it. So hopefully it will be um, helpful. Well, like I said before, what I'm making, this is a picture of what I'm making, except for I'm going to be doing just the cone part here. This is a duct reducer, and I'm going to be making a 4-inch to 2-inch. And the reason I don't just buy one of these is that they don't make a 4-inch to 2-inch duct reducer for, like you see here. And I was actually, when I was thinking of doing this a little bit differently, I was there in Lowe's, and the if I just try to use pipe PVC parts, it does kind of add up a little bit. But mostly, there's no way to have this nice cone section where you can have a gentle transition between one size and another. The air is going to be being sucked through this way from top to bottom. And if you just have an abrupt change, it can cause a lot of turbulence. And as it is, I'm not sure how well this is going to work. And I don't want to lose I don't want to lose any vacuum power to just wasted turbulence or stuff. So what I'm going to be doing is making this, for the engineers out there, at about a 7-degree angle. That's the angle that helps keep it from going turbulent. Let's just leave it at that. So what I'm going to be making is basically this. This is called a truncated cone. It's a cone that's been cut off, truncated, made shorter. Um, and remember, back when you were in grade school, you might have made a cone out of a piece of construction paper. You start with a piece of paper and you cut out a little wedge and then put it together. Well, we'll be doing something similar here, but it's going to end up looking like this because it's truncated. It's not going to be a complete cone. But one of the things about this is, if you think about it, if you cut a real narrow wedge, when you pull it together, the cone is going to be really flat. And I don't want to end up with something like this. I want to end up with something like this. So anyway, since we're trying to avoid that, I'm going to have to go through some, math is coming up. It's a few design steps. One thing we know, we're gonna, it's gonna be, at least like this. This is my guess anyway. And if you think about this, if you use half the circle, you're probably going to end up with a 45 degree here. Because if you use almost nothing, it's almost 0 degrees. And if you went to anyway, that's my guess. But more than likely, we're going to end up with something shaped similar to this, but I don't know what the angle is or anything. So this is what we're working for. And as you see, we're going to have, you've got a certain diameter here, the big diameter, calling big diameter, and then another diameter here, a small diameter. This is the height. And then we've got this angle. Well, let's give them some, just to make it easier to write out. Big D is the big diameter. Small d is the small diameter. See, nobody needs to skip to the end, skip over this chapter yet, because this is fairly simple. And h is the height. Okay, now we know that, here's a little math. The circumference of a circle is pi, just about 3.14, times the diameter. And that's true, for, big C is pi big D, little c is pi little d. Now these are going to be the size of the 2-inch pipe piece that I'm going to attach this to, and this is the 4-inch pipe piece that you already saw on the blower. So let's keep going. Well, if we take this and flip it up where we're looking straight down on it, we get that, and we get that if you're looking straight at the sides. Just to see, you get the big diameter, the small diameter, and the height. And here's the big diameter. You can see it matches up. See, right down there. So Okay, not too bad. Now, when it comes to, and this is what the piece is going to be like. We're going to, whatever the wedge shape we cut out, when we put it together, when we're looking down on it, this is where it's going to be, joined as a seam. But we do have to start talking about radius because that's how you end up actually drawing the piece out. If you're going to draw a circle, I'm going to end up needing like a stick with a nail and or either two nails or a scribe or something to scratch this out on a piece of sheet metal. I got to take the center and draw whatever the big radius is, and then draw the little small radius. The trick is finding out, how does what what radius do I need to make and what angle do I need to draw through using a protractor, just putting it out on there and measuring as I scratch the thing out. That's the trick. One thing you'll note, okay, I've gone ahead and added this in here. The circumference of this circle is, we already saw that. Okay, now here we go. The circumference of this circle is in green. Okay, well, here we have, this is in green here. This distance here is the same as this distance around. The circumference here is the same as that length because when you curl this piece together, that there becomes this circle. And the same is true for the outer. It becomes the outer diameter or the outer circumference there. So that's two things that, that we need to know. It's a good thing to know. Once we know that, the circumference of a circle is also known as 2 pi r, or 2 times the radius is the diameter. We're just substituting the radius in for the diameter here. But knowing these two, if we did 2 times the radius times pi, that would be this whole circumference here. But what we want to know is this. Well, if we just cut it in half, that would be, at 100. If this angle was 180, that would be half the length, right? Half the distance. Well, that's what it, if you want to put it in mathematical terms, the this fraction here is 360-degree circle. Whatever number of degrees that is divided by 360, that's the fraction that this length is of the whole circle. See, that's pretty straightforward. See, if this was 180 straight across, then 180 divided by 360 is half. If it's something different, that's what we got this for. And it's true for both the small circle and the big circle. Small radius, big radius. Okay, now stay with me, everybody, please. Don't skip. There's a little math here. If you actually combine these and do some math stuff with it, you'll find out, because the angle is the same for both. So if you equate those together, as you work it out, there's the fraction of the diameters, the ratio is the same for the radius and the diameters, which it's kind of makes sense. It's like the r, little r and big R, they're proportional and they're the same proportion as big D to little d. And we'll end up using it later to rearranging this to be able to calculate the little r because they're just going to pick the big one. You'll see what I mean. Okay, now if those those that don't like math can go ahead and skip to the end, or skip to the end of the chapter. Now that we've defined all these things, we're gonna do a little geometry here. When you look at the side, you've got a right triangle, okay, and the bottom is the big diameter. Well, if you take the big diameter and subtract this part out of it, what you're left with is, that's big D minus little d, but we only want half of it, so that's big D minus little d over 2. Okay. Now, when you use the good old Pythagorean theorem, you've got, I forgot to mention that, sorry. obviously this length here, that's the same, that's the exact same thing. This length here, that length is the big R minus little r. You can see that. Well, you know, a squared times b squared equals c squared, or rearranging, c squared minus a squared square root equals b squared. Here we go. We got that. That's how we find h. And then we're looking for this 7-degree angle that I mentioned before. And this angle here is, this is trig. It's, it's the tangent of this angle is defined as this length divided by that length. And then, you can solve for that. Now, we end up with, we don't know this length, or this angle. So I'm not going to solve for it. I'm just going to make myself and I already did, a little Excel spreadsheet where I put in the R and the H and the theta and the alpha calculations. They're basically, drawn from this. Okay. Um, and what I want is this needs to end up being 7 degrees. So let's just try 12 inches. Okay, we got 12 inches, 10 degrees. That's too big. So let's try 14. That's 8. Let's try 16. Oh, getting closer. 17. Oh, a little more. Let's do 17 and a quarter inch. Hey, that's close enough. Okay. Now, when we have 17 and a quarter inch, and because, the R was, we had that calculation written out there before, the little r is related. I've done that calculation, and I've done this calculation. That tells you it's about 6 inches long, which is kind of what I was looking for anyways. I just guessed, and it worked out to be about right. And the alpha is 7, but it's 44 degrees. Do that. So now we're going to have, this is going to be 17 and a quarter. This is going to be, what was that? 11 and a quarter. And I'll go through 44 inches. Okay, for those of you that skipped through the math part, after doing some calculations using the spreadsheet, found out that the big R needs to be 17 and a quarter. The little r needs to be 11 and a quarter. And the degrees that it goes through when I draw it is 44 degrees. So now we're going to go and draw that out on a piece of sheet metal and cut it out.